Hey, hi there, Graham here from Sungrow, and this is a pre-recorded training session for the Sungrow Hybrid Inverters and Batteries, and it's an installer training session, and it will be worth 15 CPD points. Once you've actually completed the video, if you can please email me. I should have the email at the end of the session and let me know. The email is training@sungrowpower.com.au. Okay, so let's move on with the presentation. Okay, so for the presentation, okay, it's assumed that you've previous experience with Sungrow hybrid inverters, so there are some things I haven't gone into too much detail about, but I will be covering the important parts that you do need to know. If you've ever installed a Sungrow hybrid inverter, if you've never done it, I do suggest that you complete the hybrid training first. Presentation here is a guide. Always refer to the owner's manual and tech data sheets because we do update them now and again. And of course, as I said, this presentation is subject to change because we do occasionally update things. So let's have a look at our complete range here. We do have a complete solution inverter and battery. The obvious advantage of that is that you can actually log directly into the battery via the iSolar Cloud. Some brands use different brands of batteries and it can be problematic, but with the Sungrow system, it's very simple. You just log in through iSolar Cloud, and it makes it easy. If there is a problem with one of the cells, we can identify that and get it fixed straight away. So on the range, the single phase hybrid, we have a 5 kilowatt, a 6 kilowatt, an 8 kilowatt and a 10 kilowatt single phase. The number of trackers depends on the size of the inverter. 3 phase, we have a 5 kilowatt, a 10 kilowatt, a 15, 20 and 25 kilowatt. Okay, so what I'm going to cover is a bit of an overview and some important data, and then we'll look at electrical and data connections, battery connections, and commissioning and testing. Okay, so we'll look at the electrical and data connections first. Okay, now for warranty purposes, in the box there are plastic bags and they come with the correct MC4 connectors, crimp lugs and bootlace crimps for the data. Please do use these. As far as the MC4s go, it is a requirement of the standards that you do use the supplied plugs. With the bootlace crimps for the data connections, you absolutely must use these, and I'll explain why later. Okay, so let's have a look at the inverter. On the left hand side, we have the DC isolator. That's built in and it's all fully compliant. On the front, we have an LED panel, nothing much on the right hand side there. All the plug and play connections are along the bottom end, and it is true plug and play. Okay, so the LED panel in the front, it's a high brightness panel, and it will show daily energy. That is the total energy for today, current AC power in kilowatts, and the current state of charge of the battery. There's a blue LED here as well, which if it's on steady, it means the inverter's all working fine. This is also a touch sensitive button. The display will go blank after a little while, so if somebody does call you up and they say the display's not working, just ask them to touch and hold the blue LED and it will go back on again. Most of our range are supplied, in fact all of the hybrids are supplied with a meter. The single phase ones, the 5 and the 6, will have an S100 meter, but all the other ones have the DTSU 666-20, which is a 3-phase meter. It's a 2-channel meter, and what I mean by that is one set of CTs will sense the mains for your import-export control, and there's a second channel which can sense the output of a third-party inverter. Now, we've got different configurations available, and I also want to talk about AC cable sizing here. Okay, so this is an example here. This is the data sheet for the 5 and the 6 single phase inverter here. Now, what I want to bring your attention to is, if you look at the battery data, it says max charge discharge power, which is 6.6 kilowatts. Now, it is possible that can be coming from the grid. For example, at night time, when there's no PV, if somebody has switched on the forced charge because they want to charge the battery up at full power, that will come from the grid, okay, and it's 30 amps. They could also possibly have the backup loads maxed up at 6 kilowatts, okay, which is another 27.3 amps. Now, that power, if there's no PV and they're charging the battery, that total power will be coming from the grid. And you can see here, in the case of the SH5RS, that's 1200 kilowatts there, okay? So that's something like 57 amps could be coming through that AC cable, okay? So you do need to size that AC cable just in case this scenario happens. So please consult your standards as to what size of cable and cable protection you will use. On the 10 kilowatt AC cable sizing, the maximum AC power from the grid here is 14.5, which is 63 amps, okay? And that, for the same reason, you could be charging the battery and you could be fully maxed up backup power at the same time. We do refer that as AC pass-through. Okay, now bear in mind, when it is backup, the 8 kilowatt inverter, the backup in off-grid mode is 8 kilowatts, and for the SH10RS, the backup maximum is 10 kilowatts. Another point to these inverters is with the 8 and the 10 kilowatt and the new 3-phase series, you can actually put the PV panel ratio at 200%. For an example, on the 10 kilowatt, the system could be passing 10 kilowatts AC out to AC and 10 kilowatts DC to the battery at the same time. So with the 8 and the 10 and the 15, 20 and 25 kilowatt models, you can have an AC-DC ratio of 200%. Okay, a whole house backup. Now this is what I was talking about the pass-through. With the 8 and the 10 and the 15, 20, 25T, they are capable of what we call the whole house backup configuration. Now this is where, as in this situation here, the entire house loads are connected to the backup circuit. Now this is where you get the 63 amps, because it could be night time and the battery could be totally discharged, and if you've got that fully loaded up to 63 amps, the 63 amps is going to come through that AC cable and out to the loads. Now if you do this configuration here, you actually don't need to install a meter. The reason for that is the inverter actually will do all the metering for you. Okay, so this is the whole house backup. Now what I'll mention about this is, yes, you can back up the entire house. When you're selling the system, you can sell it as whole house backup. Once you get the sale, of course, you can then discuss with the customer what they want to do. If they want the whole house backed up, that's perfectly okay. Or they could opt for just the emergency circuits like lighting, fridge, internet. Bearing in mind, the more loads they have on, if this goes into the backup mode and it's at night time, the longer the battery will last if they've got less loads, okay? So if they're backing up the whole home, they might only get about an hour out the battery, whereas if they only back up their emergency circuits, the battery could last them all night. So that's a discussion to have. That's not a problem. Okay, so there are times, the only time you actually do need to connect a meter, the DTSU 66-20, there's two cases, and I'm going to show you these in a moment. Okay, so configuration with loads on grid. This is where you only have the emergency circuits on the backup and you've got the major house loads just on here like this. In this case, you will need to install the meter because it's the only method we have of measuring consumption to the loads, okay? So if you have normal loads, yeah, you will need the meter. Another time you will need to put that meter on is if there is a third-party inverter, AC coupled. You install the meter and you put channel 2 CTs on the output of that. There is a separate training module for the meter and documentation for the meter. I'm not going to go into it in too much detail on this one here, but I do suggest you do that training as well. Now, if you look at this diagram here, it does say panels optional. This is to do with AC and or DC coupling. I'm going to go back a slide to here, okay, just to explain what AC and DC coupling is. This is DC coupling because what you're doing is you're charging the battery, which is DC, directly from the DC output of these panels. Obviously, the voltage is controlled, but when there's a surplus production, that is the system's producing more power than the loads are consuming. Instead of that energy going out to the grid, getting the feed-in tariff, it will go directly to the battery and charge the battery. In this scenario here, if you have panels connected, that is DC coupling, but you can, say, not connect panels and use the third-party system to charge the battery. This is AC coupling. Now the way it works is pretty much just the same. If this system here is producing more power than the loads are consuming, instead of exporting out to grid, the inverter will charge the battery from the AC to the DC of the battery, like this. So that's AC coupling. Now you might come across this, for example, if somebody already has a PV system installed and they want batteries, you can AC couple quite easily. You could replace the existing inverter if you want to. That's fine, you can do that. Bear in mind, however, if you do replace that inverter, you will become responsible for the warranty of the whole system. Whereas if you AC couple, you're not responsible for the warranty for this stuff here. Okay, now, if the grid fails, and I'll explain the backup. In our inverters, the backup is actually built into the inverter. There's no requirements for any external equipment. It just comes as in the same price. There's no extra cost for the backup. All you need to do is enable the backup when you commission the system, and it's all ready to go. So, if the grid fails, this inverter here is also going to switch off because it's a grid connect inverter, and if it loses grid, it shuts down. Now in this, so basically you've lost all this here, okay? So in this scenario here, the inverter switches over to backup mode. It will decouple from the grid anyway, and it will become grid forming. So it will, if there's PV panels connected and or battery, it will then feed grid AC 230 volts, 50 hertz out here and supply the backup loads. Now, if you don't have panels connected, it will run straight from the battery, and it will do this until the battery goes completely discharged, then it will shut down. If, however, you do connect panels to it, it will black start the next morning. Now, what I mean by that is if you do discharge the battery completely overnight, the system shuts down. The next morning, as soon as the sun hits the panels and some DC voltage starts coming down the line, the inverter will wake up and it will start operating as per normal. It will supply the loads, and only when there is more power coming in than the loads are consuming, it will then charge the battery. So this is like a completely off-grid system, and it will remain like that for as, like if the power's off for a week, that's fine. As long as they don't drain the battery too quickly, the system will just be in operation as an off-grid system. Alternatively, one thing you can do is if you do have it AC coupled and you want the system to keep going, you can, under certain some circumstances, connect that third-party inverter to the backup circuits. Okay, as long as this inverter is not bigger than the Sungrow. Like for example, if you've got an SH5 RS, this can be anything up to 5 kilowatts, but not larger, okay? And it must be able to respond to frequency shift. Now, you know the ES4777 says if the frequency goes above 52 Hertz, then the inverter must shut down. That's how it operates. So in the off-grid mode, if the system is producing more than the batteries and the loads are going to consume, it does have to ramp down. It can't produce more power than is being used. It will ramp down, but it will also lift the output frequency to 52 Hertz to shut this other one down as well. Okay, so that is how it controls the other inverter output. Obviously, when there is demand for power, it will drop the frequency back down to 50. This inverter here, after 1 minute, will come back in because it's detecting grid frequency and voltage. Okay, the output voltage will be 230 volts, by the way. And you do have to, there is a setting, if you are doing this, let us know. There's a setting where you actually enable that feature. So in this case here, you can AC couple and put the third party system onto the backup circuits, and that will keep going every day. Obviously when the sun goes down, this inverter here shuts down as normal, but when the sun comes back up, as long as this is in operation, pumping out grid voltage and frequency, the inverter will start up. So if you want to do that and you're not quite sure, give us a hoy and we'll give you the information. Okay, AC connections look dead easy. Because of the high power of the AC, it's a fixed wiring. Okay, and the crimps are in the box. Please use the correct crimps, and of course please try and avoid one of these things, because if you strip the threads, basically the inverter's not usable. You can't really repair it, can you? So yeah, just use your hand tool for that, and if you are using some kind of wrench, there we are, 2 Newton meters. It says this in the manual, so there you go. Okay, now earthing. Now this is mandatory. It is in the manual. If you look through the manual, for Australia, New Zealand, South Africa, sorry, because we use the MEN system here, you do have to earth the chassis of the inverter. Okay, on the side or underneath there is an earth terminal. You'll see it clearly marked. Now the reason we need to do this is because the system, when it goes into off-grid mode, it will completely decouple, and including the earth. The internal earth of the backup is not connected. Okay, so you do need to earth the chassis back to the earth bar to pick up the earth neutral link. Otherwise your RCDs are not going to work. Okay, so yes, you do have to run an earth cable. As far as what size, just refer to the standards. That will tell you what size of earth cable to run. But yeah, you just run from the chassis back to your earth bar and you'll be fine. Changeover switch. We now include changeover switches. Obviously it's a 3-pole changeover switch on the 3-phase models. This is simply because there are a couple of reasons. One is that in places like Victoria, for example, when you install a system, you're not allowed to actually switch it on until it's been inspected, I believe. So what you do with the changeover switch is you install the system, make sure it's working, and if you've got the whole entire house on backup, there's going to be no power because the inverter is switched off. So you just switch this through the contacts to the center off and on to grid. So the customer is basically still connected to grid, and you let them know that when the system switched on, they switch this back up to the inverter like that. It's also handy if for some reason, if the inverter fails for some reason, so that they can back onto grid supply. So this is a single phase one shown here. We do have a YouTube video on how to do it properly. It's dead easy. If you haven't done one before, it might look a wee bit complicated, but once you've done one, it's dead easy. So we include these in the box. PV connections, I shouldn't really have to dwell on this. I think you all know how to do it. Just make sure, as I said at the beginning, you use the correct plugs that we supply in the box, and make sure that you do crimp this correctly. If you don't crimp it correctly, you're chancing overheating at the junction and the plug may melt. MC4 for the DC connections, and the battery, which is this one here, is Evo 2. All of our inverter range now are 16 amp IMP on each input there, and it's a 20 amp ISC rating. These are 50 amps for the battery, or 30 amps, sorry. Now, communication. I say the AC and the DC is quite straightforward. You just connect it up like as you normally would. I'm sure you can do that. Communication is where I'm going to spend a bit more time on that, because it is a bit more involved. Inverters didn't used to have all this on them, but now they do, so you do need to learn and know what you're doing with the communications. Okay, on the left hand side of every one of our inverters will have one of these, a pinout diagram, okay, and it tells you where to connect everything. For what we do, there's only two of the terminals that we use. The meter A2, B2, and that's to connect the energy meter, and the CAN is for the battery, CAN high, CAN low. These are the only ones that we use, okay, like that. Now, depending on which inverter you have, they might not be in this position. It just depends on the internal hardware, okay, it's how they come in the pinout thing. But it is marked meter and CAN. Now in this drawing here, you can see the numbering. It goes 1, 3, 5, 7, 9 and 2, 4, 6, 8, 10 at the back. And if you look here, it says CAN high, low, and that's the CAN there. So this is from the battery, this one here. And you'll see there's blue crimps, okay? These are the crimps that we supply in the box, and they're longer than the standard size. They have to be, because you push them in to the terminal to get the connection. If you don't use these, you will almost certainly get a bad connection, and you'll get data dropouts and stuff like that. And the last thing you want to do is have to go back out onto site just to remake one of these ends. So you just crimp them and they push in. If you need to take them back out again, there's a little white block there with the spring. You just push that in and you can take these back out. Okay, so the meter would be going into 1 and 3, and the battery into 2 and 4 there, okay. Like that, yep. Okay, meter connections, right? All the necessary connections, including the COM cable, are included in the box. Now you must use the stuff, if possible, that we supply. Obviously, if the meter cable, I think it's supplied about 8 meters or something. If it is longer, you're going to have to purchase some cable for that, okay? Now, the meter always communicates via RS485, okay? RS485 is a specific data protocol, and there is actual RS485 cable, which is shielded twisted pair. Always use that. 0.5 mil or larger cross-sectional area. A lot of people like to use Cat6. Yes, it can work to a degree, but it's not quite the correct cable, and you may get problems with communications. Really seriously purchase and use the proper shielded twisted pair cable. It is also RS485 is a 120 ohm impedance system, and the proper cable is rated at 120 ohms as well. So I recommend not to use the Cat5 or Cat6. If you do, well, it might work, but it might not. terminate with the correct bootlace crimps, as I mentioned before. Okay, so the meter gets connected into meter A2B2 like so, like that. A2B2 is marked A and B at the meter end, and A2B2 across all of our range. The meters always communicate on A2B2. Okay. You'll see RS485A1B1, that is for inverter communications. Don't worry about that just yet. Okay, so here we are, A and B on the meter and A2B2 at the other end. You will also get in the box these little 120 ohm resistors. The purpose of the resistor is called a termination resistor, and what it does is it stops data reflections in the cable, so it's going to improve signal quality. So I do recommend that you do that. If you don't do it and you're getting problems with dropouts, put it in anyway. So it'll only take you 5 seconds, and you basically just bend it over, put it in like that. You can do it at this end, at the plug, but that end is a lot easier at the meter. Yeah. Okay, now the battery. Now this is a big one, because we get two ranges of batteries. We've got the SBR range, which is the residential range, and the SBH. We are using both. The main difference between the two is the amount of power output. The SBRs are more designed for residential. They discharge at 30 amps. The SBH are a higher output, and they're designed to be used with the three-phase inverters. They charge and discharge at 50 amps. For the sake of this training, I'm just going to talk about the SBRs, but it's the same for the SBH, okay? Now, the maximum number of modules in a series on a battery stack for the single-phase hybrids is 6, okay? And I'll explain why in a moment. That's 19.2 kilowatt hours. And if you are using a three-phase inverter and the SBR batteries, the maximum is 8 modules, okay? 2 stacks can be connected in parallel as long as they're equal. So if you've got like a stack of 6 batteries and you want to increase the capacity, you can put another stack beside it and connect them across in parallel. You can do 3 or 4 stacks, but you need to use a combiner box for that. Now, I'll just mention here, if you have a stack of 19.2 and you add another stack of 19.2, what you're going to do, the voltage will remain the same and the current will remain the same as well. It's only the capacity that you're increasing, okay? Just bear that one in mind. So it's 19.2 times 2, which is 48.4 or something like that. We do have full instructions how to do it on our webpage. So if you are going to be doing anything like that or adding modules, please talk to us first, and we'll send you out the instructions how to do this. Batteries are not as straightforward as PV, okay? They're a bit more analog. So there is little things that you've got to bear in mind. Always consult the data sheets. Okay, connecting the battery could not be simpler. You get basically positive and negative power cables. Use your normal 6mm PV cable for that, that's fine. There's a communication cable in the box. It's terminated at one end with an RJ45 with a lockable boot on it, and the other end is just terminated like this. We use, on the systems we use the 568B configuration, which means you're using pin 1 and pin 2, which is CAN high, and CAN low, which is white, orange, and orange. That is the only 2 you're going to use. Ignore the rest, okay? So CAN high, CAN low is white, orange, and orange, which, as we said before, connects to high and low there, okay, with the little blue crimps on them. So that's nice and easy. Just neaten that. When you strip it back, you know, just put some heat shrink over that end and make it nice and neat. Sizing the battery. Okay, now this is probably one of the bits that I do need to do a lot of training on. Okay, so this is from the data sheet. Okay, this is the SBR range. There's a couple of things you need to, the two main things with the battery is capacity and the rated DC power, okay? So when we're talking about capacity, the more modules you've got on, the more capacity, which is quite obvious. So if you see here energy usable, that's the capacity of the systems there, okay? And obviously you need to be able to make sure that you're going to actually charge that capacity every day. Also take note of the voltage, okay? These are series connections, and the inverters, okay? Each inverter, if you look at the data sheet, it will tell you the maximum battery voltage input. So you cross-reference this stuff here. Now, I happen to know that the maximum battery voltage input on a single phase hybrid is about 500 volts, okay? So 6 modules, yep, the maximum there is 438, that's fine. But if I put 7 modules on, the maximum is 511 volts. So the voltage is too high, okay? So that's why I can only put 6 modules on like that. This is the rated DC power, okay? So that's the maximum power that's going to come out of a battery stack. Now this is the important one. For example, if somebody installs a 10 kilowatt hybrid, an SH10RS, and they want 10 kilowatts on the backup, right? If you sell them 3 modules, okay, the maximum out of that is 5.76. So you're not going to get 10 kilowatts at all. You're only going to get 5.76 kilowatts out of there. If the loads try to consume more than that, the system will trip, okay? So if somebody does want to get 10 kilowatts of power available on the backup, you're going to have to go up to this size here, 6 modules, okay? Bear in mind, 2 of these in parallel, this is all going to be the same except the capacity will double. The voltage, the current, the power is going to be the same. So they need to go to 6 modules. So if they are buying 3 modules, just make sure that you don't connect more than that 5.76 kilowatts onto the backup loads, okay? It's fine if there's PV there as well and if there's grid there as well. But at night when there's no PV and if the grid goes off, you are reliant entirely on that battery, okay? So these are the critical things to look out for, cross-referencing it with the inverter. Do the same on the SBH range, okay? Yep, they can start with 2, oh yeah, they can start with 2 modules. Now you can add modules, which I think, I'll get on to in a minute. Okay, so the SBR, SBH ranges have different voltages and current ratings. Just bear that one in mind. Okay. Okay, so if you're doing a parallel stack, give us a hoy and we'll send you the information. Okay, now on the power cable between the battery to the inverter, it's a parallel connection. Okay, so you're actually going positive to positive and negative to negative. Okay, so as in here, positive to positive, negative to negative. If you do positive to negative and you connect it up, when you switch the inverter on, you'll get the red fault light. It won't blow up or anything, it'll just come up with fault and it will tell you the fault code is incorrect polarity. Okay, so bear that one in mind. Now, communication cable, this is a locking ring here. It must actually lock 2 reasons. One for the IP rating, it's IP55, and the other is to make sure that there's a proper connection. Now, if you do it with your hand, it will feel really tight and you think you've got it into place, but it's not. It's got to actually like kind of click into position. So we provide this little tool here. It just slots over the cable onto there and you turn it and you'll actually feel it clunk into place and you know it's locked. If you don't lock it, it will work loose and you've got a communication error with the battery. As I said, the system is IP55. We've submerged these batteries in water, everything, and they're fine. The only weak point is if the water runs down this power cable and into the MC4 there. If it hasn't been tightened up properly, the water can get in there, okay? Now we do have something on the manual about that, and we do advise to put a drip loop in as well. If you're an off-grid guy, yep, all of our hybrids can work in off-grid mode. All you need is a generator big enough to supply loads and charge the battery with a 2-wire start. Okay, now that's a totally different training thing altogether, but they can go in full off-grid mode. Okay, dongles. So once you've got it all connected up, they're all connected with a YNET S dongle now. All the commissioning and connecting to the iSolar cloud is done through the dongle. Okay, and it's dead easy. Communicates on 2.4 gigahertz. So normally you're going to, I say, use your phone, which I'll show you in a second. You're going to communicate to the customer's modem via Wi-Fi, I say on 2.4 gigahertz. If the range is more than 10 meters, or if the customer has a 5 gigahertz only modem, okay, you can purchase these Wi-Fi extenders. You can get dual band extenders that operate on 2.4 and 5. TP-Link ones, we've tested them and they're quite good. So if you do get a range issue, you can extend the range, or if it's a 5 gigahertz only modem, yeah, you can do that. Alternatively, if you unscrew this little thing at the bottom here, there is an Ethernet port, so you can actually hardwire. This is quite handy for new build where they don't have internet, and you just hardwire back to where their modem is going to be, okay? And you put a wee label on it, it says, you know, solar system, something, and you can get it all commissioned up. You can commission the thing, you can get it on the iSolar cloud, everything is ready to go, so that when they move in, they switch the power on, everything starts up, and they just plug that in there and they're connected to the cloud, and that's it all done. So that's quite a handy way as well. Or if you do have Wi-Fi issues, like Wi-Fi range or something like that. Another alternative, if there's no Wi-Fi on site, is you can purchase these dongles, the 4G dongle. It's an IM4 4G, and it comes with a SIM card, 5-year prepaid data plan. I don't know the cost of these, but they are an optional extra. Okay, so when you switch on it first, this blue LED on the display will pulse off and on slowly once every couple of seconds. Say if it goes red, there's something not right, and if it's not lit up, there's no power. You can do this with either or, AC, DC. You can do it with just AC or just DC, doesn't matter, it's fine. All commissioning is done via the iSolar Cloud app, so if you don't have an iSolar Cloud account, you need to register as an installer to get your account. 3 parts to commissioning, it's dead easy. The first thing you're going to do is create a plant on iSolar Cloud. You're going to connect to the end user's modem and through to the internet, and then you're going to initialize the inverter, i.e. set the grid standard, okay? And it's all done. If you on the top right hand corner, I think that's black now, but there's a little plus thing. You just tap that and you just follow the prompts, okay? It's really quite easy. So you go through, you name the plant and all the rest of it, and you go the type of plant it is, and you get it up on the iSolar Cloud. When you're initializing it, you set the country to Australia. This is an old screenshot, but you'll normally select Australia A or B or C, depending where you are. If there's feed-in limitation on the site, look, if the feed-in is 5 kilowatt max and you get a 5 kilowatt inverter, you don't need to do anything, obviously. But if you have a 10 kilowatt inverter, you will have to enable the feed-in limitation. Set the feed-in limitation value here. Okay, so supposing it's an SH10, or if you've got another inverter, you need to control that. Now, you cannot control the other inverter, by the way. You can only control the Sungrow. Rated power of original power generation systems. If there is another inverter on the same phase, and it's a 5 kilowatts, you've got to add that in there. So in this case here, we had a 5 kilowatt inverter. We've set the feed-in limitation at 5 kilowatts. There's another 5 kilowatt inverter on site, so it's 50%. And that'll calculate on the total coming out through the meter, okay? Don't forget to enable the backup mode. Okay, you just tap that till it goes green. Like so, okay. Now the inverter will start, it'll go through a startup phase. Now the first time you start it up, it could take 2 or 3 minutes to actually start up. Don't worry about that, just let it go through because it's doing all its settings and stuff like that. If you are setting it up as whole home backup, you do need to enable, if you go to the settings, energy management parameters, you do need to enable the whole home backup. If you forget, doesn't matter, you can do it afterwards on the iSolar Cloud. All of the settings, all of them can be done on the iSolar Cloud. Obviously, if you get the system up on iSolar Cloud, it's not a problem to do everything, okay? We do have the Service Partner Program, but before I go to that, one last thing. When you do commission a system, now, the equipment that you've installed might have been manufactured maybe 6 months ago, okay? And during that time, we may have enabled more functionality, or we may have ironed out a bug, okay? So when you do a system at first, please always update the firmware as part of your commissioning. It can be done in the background on iSolar Cloud. We've got videos showing you how to do it. Make sure you update the dongle, the inverter, and if you've got a battery fitted, the battery. And you do that and it shouldn't be any problem. Okay, Service Partner Program, if you are interested in becoming a service partner, just go here on the website and fill in the information. We're always looking for service partners. Okay, now did I have, yes, okay. To claim the CPD points, you'll need to email training@sungrowpower.com.au. You'll need to include your first and second name, the course you attended, which is this one. It was a CPD191. You have to tell me exactly which one it was and when you did it. And I will have to send you out a questionnaire with some questions on it, what we've been talking about. And once you've done that, I can issue the certificate that you get your CPD points. So thank you for watching. If there is anything you're not sure about, training@sungrowpower.com.au, just flick me an email and ask a question and I will get the answer out to you.